We all know the Aurora Borealis are a spectacular display happening above, but do you really know what causes it? What is the Aurora Borealis?
When we watch that dazzling display of light, it's actually telling us a story. It's a story that began on the sun, traveled all the way to Earth, had a series of interactions in the magnetic field, and led to this beautiful display overhead.
The Aurora Borealis are caused by particles, electrons and protons, blasted out from the sun in all directions and colliding with gases in the Earth's atmosphere. Those particles travel 150 million kilometers from the sun to reach Earth. That can take from 2 to 4 days. That flow of particles is called the solar wind.
A lot of particles, when they reach the magnetic field, are deflected away into space, but some become trapped in the magnetic field. And what's going on is that there's this little spark that occurs, this release of energy that we see in the form of light. And so now imagine that overhead there are billions of these tiny little sparks going on. And the sequence of light, these little flashes of light, are what we see and call aurora. So if you're living in northern Canada or northern Scandinavia, northern Russia, around the North Magnetic Pole, and you look up, what you're seeing is this waterfall of particles that are following a magnetic field line into Earth's upper atmosphere.
So why are they different colors? The Earth's atmosphere is made up of nitrogen, oxygen, and other gases, commonly known as air. The colors of the aurora depends on the gas molecules that the particles are mixing with. So green, the most common color of aurora, is a charged particle mixing with oxygen. Blue is when they mix with nitrogen.
Generally along the lower edge, we see a really intense, very vibrant purple color. That's an indication of particles interacting with nitrogen.
Astronomer and physicist Galileo actually coined the term Aurora Borealis in 1619. It was after Aurora, the Roman goddess of morning. He mistakenly thought that the auroras were due to sunlight reflecting from the atmosphere, according to NASA, though indigenous northerners have oral traditions about the lights that go back generations. How high up are the auroras? Aurora are between 100 and 500 kilometers above the surface of the Earth. How high is that? The International Space Station orbits the Earth at about 400 kilometers above the surface. Astronauts on the space station often get a side view of the aurora.
That's still cool too, because the side view of an aurora can give you an unbelievable show. It shows you how tall an aurora can be.
Saturn and Jupiter also have beautiful auroras, even more powerful than Earth. There is a lot of mystery around the aurora, though. Scientists are always looking at new missions to better understand the relationship between the sun and the Earth and forecasting auroras and space weather. Modern-day technology like cell phones also depend on that research, since satellites can be affected by the solar wind. So why are aurora more visible in the north? Well, most auroras occur in a band called the auroral oval. That's a huge ring of aurora above the Earth's north and south magnetic poles. The northern lights we see are just a small section of the auroral oval. Places like Alaska, Greenland, Scandinavia, and northern Canada are the perfect zone because they're close to the auroral oval. If you're at high latitudes anywhere on the planet, chances are every single night there is auroral activity overhead. When there is active space weather, it can push the auroral oval like an elastic band further south. That's when people right across Canada and even the United States can see the aurora. And let's not forget the southern lights. People living near the South Pole can see the Aurora Borealis' cousin, Aurora Australis.
It's really, truly a scientific wonder. And there's a lot that we still don't know about when it comes to the aurora. Some of the most experienced scientists say that for every question that's answered, there are 10 more that need to be answered. It's a beautiful way to watch the sun and the Earth and their magnetic connection. And it tells a beautiful scientific story.